Hi, welcome to you all. I'm Dr. Varalakshmi, working as a faculty in the Department of Organic Chemistry, Sri Padmavati Mahila Vishwavidyalayam. Today we will discuss the topic on base hydrolysis. Base hydrolysis, it occurs in the basic solution. pH is greater than 10. In the previous class we seen that acid hydrolysis. In the acid hydrolysis, its pH is means less than 3. Two types of mechanisms in octahedral complexes we see, that is SN2 or associative mechanism, SN1CB or dissociative mechanism. In the acid hydrolysis we see only the dissociative mechanism. What is SN1CB mechanism is means why is SN1CB mechanism is more favored than that of SN2 mechanism means acid base properties of the complexes are more important than the nucleophilic properties of the hydroxide in case of SN1CB mechanism. Reactions occurring in non-hydroxylic solvents like DMSO dimethyl sulfoxide can be explained by SN1CB mechanism but not by SN2. What is SN2 or associative mechanism? In the first case, this is the complex as we are doing addition of hydroxide, so it is base hydrolysis as we know. The first step is the slow step as it is the which is the rate determining step, means slow step is only the rate determining step according to the kinetics. What happens in this one means there is addition of hydroxide ion takes place. The later it is this leaving of one of the means ligand chlorine here results in the formation of the base hydrolysis complex. See, in the first step what happens means association of the respective hydroxide ion, so it is associative mechanism. In the first reacting complex, the number of metal means ligands attached to the metal are 6. In the intermediate, as it is associative, coordination number is increased to this is 5, 6, 7, 7. Later, with the displacement of chloride ion, the octahedral complex is formed. What is the rate of the reaction for this base hydrolysis means? Rate of the reaction depends both on the concentration of the complex as well as on the hydroxide ion. So, rate we can say that is second order kinetics. Why? Because means both are involved in the rate of the reaction. Means rate of the reaction depends on both the concentration of the reacting complex as well as the hydroxide ion. Then what is SN1CB or dissociative mechanism? See, this is the complex and this is the hydroxide ion which is the base. This is the first step. What happens, see, if you observe means what happens. Here in the initial reactant, number of ammonium ligands are 5. Here how it is arranged as such that NH3 taken 4, NH2. From the NH2, one of the proton is taken up by hydroxide to form H2O. Now this is acts as a base. Initially it is an acid. This is the complex which is acid. By removing one of the proton from NH3, this complex converts as base. Whereas hydroxide here it is attacking complex. Initially it is base. Taking the proton from the respective reactant from the means this is from this one, it turns to the means converts to the acid. To this one, to the respective associated means a base one, which is coordination number 6 only. What is the next step means there is dissociation of the Cl minus from this respective complex. Then what happens means if you see the complex converts to the 6-membered complex, means 5-membered complex. Initially it is 6. By the dissociation of the chloride ligand, it converts to the 5-membered complex. What is the rate means it depends both on the conjugate base. Here the rate depends on the conjugate base only. If there is no presence of conjugate base, we can't define the SN1CB mechanism. How the means respective concentration of the conjugate base, how we can write means K into respective complexes, means what we are taking here, the reacting complex, this one, as well as the hydroxide by H2O. There is a diagrammatic representation related to this mechanism. Initially, this is the octahedral complex. This association of the, there is means as we are saying association no in this base hydrolysis, as but in the case of acid hydrolysis there is this association takes place. Here in this base hydrolysis there is association of the ligand takes place such that this octahedral 6-membered complex converts to the 7 coordinated intermediate complex, which is unstable. See, to the metal, number of ligands are arranged or in a 7 in number. 1, 2, 3, 4, 5, 6, 7. They are arranged such that as 7-membered coordinated intermediate. With the fast ligand displacement X from the respective complex, it converts to the octahedral complex. Then we discuss the trans effect. Then what is trans effect? Trans effect means the tendency of an already attached group to direct the incoming ligand to its transposition in ligand displacement reaction. Means attacking ligand means presence of group present in the metal complex. It directs where the incoming ligand should be placed. If it is trans in position, we can say that is trans effect. These will take place in the complexes which are square planar in nature. What is the trans directing ligands series means? This is the trans effect series. The first one is the higher trans effect is cyanide. E means C2H4, CO, NO, SN minus, I minus, Br minus, Cl minus, pyridine, NH3, hydroxide, H2O. This trans effect shows in only the square planar complexes. Square planar complexes generally shown by the metals with the D8 configurations. Cobalt plus, rhodium plus, iridium plus, or nickel 2 plus, palladium 2 plus, platinum 2 plus, copper 3 plus, silver 3 plus, gold 3 plus. Here in this square planar complexes, whether it is association or dissociation means only there is association of the ligand initially takes place. See, if you see Ml3X plus Y results in the formation of Ml3Y plus X. Here the rate of the reaction depends on the reacting complex as well as attacking. So it is second order kinetics. Depends on the nature of the leaving group as well as the entering group. If there is any steric crowding in the reacting complex means it slows down the reaction. As we know that it follows the associative mechanism. What is the application of trans effect means? As we know, platin it's nothing but a platinum which contains 2 chloride ligands and 2 ammonia ligands. They are arranged in 2 different ways, means isomeric forms are there. First is cisplatin, another is transplatin. Cisplatin it's nothing but presence of ligands are in cis in position, whereas transplatin, in the transplatin, see similar ligands are arranged in such that they are trans in position. Then next criteria, how we synthesize the respective cisplatin and transplatin. In the case of cisplatin, how we can prepare means we have to take PtCl4 2- complex. If we treat this complex with ammonia, what happens means there is replacement of chloride takes place with the attack of one of the ammonia to anywhere to this respective complex. See, this is the complex we can get. To this complex, we are doing another mole of addition of ammonia. Then what is the criteria where this ammonia has to attack? Means where to has to be placed. From this, for this thing, we have to follow the trans effect series. From among these ligands, chloride and ammonia, which is having greater trans effect means chloride is having the greater trans effect. So, either this or this can be replaced with the ammonia, results in the formation of the cisplatin. Next, See, from the to this Cl and ammonia, as I am said, chloride is having the greater trans effect. So this cannot replace this one. If it is very greater trans effect means it can replace this one. But this is only the greater trans effect among, means chlorides are only the greater trans effect. So either this chlorine are replaced with ammonia forms the cisplatin structure. Then preparation or synthesis of transplatin. Here initially what we are taking is platinum with the ammonia as a ligand. Platinum which contains 4 in number of ammonia ligands, means 4 ammonia ligands are bonded to the platinum metal. To this complex, initially we are doing the chlorine addition, attack of chlorine ligand to this respective complex. What happens means any of the ammonia is replaced with the chloride. Why? Because means chloride is the greater trans effect from the trans effect series. So chlorine can sit anywhere among by replacing the ammonia. Let us consider as we are replacing ammonia here and we are keeping this chlorine to this respective position. Then what is the second criteria? We are doing the addition of another mole of Cl minus. Then this Cl minus where has to be placed? It's the second one. Where has to be placed means from this chloride and ammonia, from the trans effect series, chloride is having the greater trans effect. So it can displace its trans effect ligand, means position means to this chloride, whatever the ligand arranged in trans, it can be replaced easily with the chloride. Why? Because means chloride is greater trans effect. So results in the formation of transplatin. Another preparation of isomers of this respective complex. Let us see example for this. This is the complex we are taking, the trialkyl phosphorus. All the 4 trialkyl phosphorus are arranged such a way that they are in square planar structure. As we know, to this platinum respective metal complex exists in the square planar structure only. We are doing attacking of chloride to the complex. What happens means there is a displacement of one of the PR3 with the chloride. This is the complex attacking of chloride. We are doing another mole of addition of chloride. What happens means let us consider the trans effect nature of PR3 and Cl. What is happening here means, what is happening if it is chloride is greater than trans nature than the PR3, it can replace this one. But PR3 is greater trans effect, so chlorine will attack this position, forms the cisplatin. See another one. All the chloride ligands are attacked to the metal. What happens means, the first case we are doing the addition of trialkyl phosphorus to this complex. One of the Cl is replaced with the PR3. Later with the addition of another mole of PR3, what happens means, as we know that which is greater trans effect series 1, PR3 or Cl minus means PR3 is greater trans effect. So PR3 replaces the ligand which is in trans with the PR3. Here Cl minus is replaced with the attack of PR3. So there is a formation of the respective trans isomer. Thank you.